I think we're live. Can you hear me? All right, well, welcome to our next session here of a UCR virtual open house. Today we'll be talking about some of our exciting master programs that we have ongoing here in the Department of Chemical and Environmental Engineering. If you could forward that slide. So I'll give a quick welcome and then we'll pass it off to discuss graduate admissions with Professor Ian Wilden, who will then give us a program overview of one of our MS options, our biotechnology. We'll follow with Professor Jinyoung Liu, who will be talking about our MSOL water quality. And then Professor Don Collins will be talking about our newest air quality master's programs, both in person and part of the MSOL. And we'll have a moderated Q&A, and we'll close from there. But I just want to say a couple words of welcome. This is a very exciting time here in the Department of Chemical and Environmental Engineering. We have a number of active programs, both at the undergraduate level, master's level, and PhD. We have research that spans many different areas, from advanced materials and nanotechnology to air quality systems engineering, biotechnology and biomolecular engineering, computation, molecular modeling, energy conversion and storage, and water quality systems engineering, all of which are research programs that you can be involved with if you select part of the MS thesis option. Otherwise, you'll be taking a number of courses from our elite faculty here at UC Riverside with specialization into the area of interest, from general chemical engineering to our more specialized programs, like I said, in biotechnology and air quality systems, or in water quality systems. With that, I'm going to go ahead and hand this off to Professor Wielden, who will start off with the graduate admissions. Welcome.
Great, thank you, David. Sunny, were you going to go first, or is it me?
I'll take over just for a second. Hi, everyone. I'm Professor Ivy, environmental engineering professor, and I just want to share with you some of the interesting stats about UCR and the College of Engineering. So we are #1 in social mobility, meaning that when you enroll at UCR, your chances for improving your life expand tremendously. We're also #12 for the public universities in the nation, according to Forbes, and we're in the top 50 for public engineering colleges. So getting your master's at UCR is a great choice. And with that, I will go ahead and hand it over to Ian, who'll talk about the graduate admissions program.
Thank you. That's me. Welcome. I'm part of the graduate committee and the past chair of the graduate committee as well. And so I guess I'll just speak a little bit about, the program and, some of the metrics that we're proud of. And then I'm also the spearheading the master's program in biotechnology. And so I'll spend most of my time talking about that. But this is a little bit about our department. We're almost 400 undergraduates. And I think some of you are probably on the line now. And so this includes you. We're also about nearly 100 graduate students, about 84 students from chemical and environmental engineering proper, and then also maybe about 20 or close to 20 from other departments join us in our research groups. We have 21 faculty, and you can see by the numbers on the bottom that we've increased that faculty size quite a bit in the last 9 years or 10 years now. It's 2021. And so we've grown considerably, both in the graduate student population and in our faculty population. And I think our successes here is also shown here. We've got a number of faculty who have been winning the Young Investigator Awards, and I think this speaks pretty highly of their early research careers. Also, we've been able to generate a lot of extramural funding or federal funding for our research, and it's about $600,000 per faculty. That's an impressive number that we're proud of. So next slide, please, Sunny. Thanks. Great. And so I think some of the numbers that we just looked at really speak to how dynamic our faculty are and how productive we are. And I think this is impressive given the relative youth of our department, and also the fact that a number of our faculty are just starting out, and they're within about 5 or 6 years of starting with us. And so I think as a master's student, that provides a lot of opportunities to interact with those research groups or get involved in research, even if you're in a course-based master's as well. And so we also have 4 research centers, and I don't think I'll remember them all at this point. One is the Center for Industrial Biotechnology, which I will certainly remember because it's one that I spearhead. There's also CCERT, which David and Don and are involved in, and Sunny as well, actually. And the other 2, I don't remember actually. The Winston Chung Global Energy Center, and then there's probably another one that is escaping me right now. And so, those provide you as a master's student with a lot of opportunities to interact with faculty and with their research groups, and they're actually quite strong research groups. And so there's a number of opportunities, I think, on the master's side, and we'll talk about this today. The biotechnology option I'll talk about shortly. Dr. Collins will talk about the air option, and then Dr. Liu about the water option as well. And so these are available to MS students and then also BSMS students. So the BSMS is a 5-year program for undergraduates that are already with us, and you can transfer from your 4th year into that 5th year of the MS program. And typically the master's programs we're talking about today are course-based or and not thesis-based. There are those 2 options, and so you could come to the department and think of a thesis-based or a research-based master's. That's typically 2 years or 1.5 to 2 years. And a course-based option is really limited to about 1 year of course work, and that kind of depends on which concentration you're going into. But I would say that all of the degrees that we're going to talk about today are programs in chemical and environmental engineering. And so your degree, your master's degree, will be in that field. We're now going to talk specifically about some concentrations you can do within there. Again, that's the industrial biotechnology or the air or the water focus, right? And so those courses will be slightly different across those fields, but your degree will be in chemical and environmental engineering. Okay, next slide, please. Oh, great. So this is a little bit about Riverside and about things that we think are attractive to Riverside. Again, many of you on the call, I believe, are undergraduates from us, and so we don't need to convince you how great Riverside is. But this is just a slide to show you that there are a number of things that are very closely located to Riverside, and there's a lot of opportunities to reach outside of Riverside. Certainly, I guess we'll have to wait until COVID passes before we go to the beach or to the mountains, but certainly these are available when we get back to in-person classes. Next slide, please. Oh, there I am again. So now I'm going to talk about the biotechnology master's program, and we can go right into the next slide if we could, please. So this is a program that is a 9 or 12 months at most program that will really provide you a very focused and dedicated set of skills for industrial biotechnology. And if you're following the news at all lately, then you'll know certainly that this is an important part of our national infrastructure as well as worldwide, which is where you will learn in this program how you can manufacture and how you can apply your chemical engineering skills to the biochemical and bioprocessing industry. That is, how do we make vaccines, or how do we make antibodies, or how do we make ethanol for fuels in our cars, or how do we make more advanced biofuels as well? Those are all topics that we can talk about in here, that we will talk about in this program, that you'll learn about. So this is one of only a few different programs across the country that do this. There's a number, there's a couple others in the Northeast, and then one in Chicago, and then one locally at the Keck Graduate Institute. But I think ours is particularly interesting because it really does focus on manufacturing and how you can understand and design different bioprocessing plants for a number of different products. And so there's also some 4 different research areas that I'll talk about in a minute on the next slide. But really what we're talking about and learning about in this program is how to do manufacturing using biology. One of the things that I'd like to emphasize here before we move on is that the difference between 9 and 12 months here is depending on when you do your internship. And that internship is an important part of this program and is a necessary part of this program. What that is that at the end of your classwork or during your classwork, you will go out into industry or into one of the labs on campus and do a practical internship. And that's a integrated part of the program that I think really provides you with some hands-on skills and some real new skills that you might learn in industry as well that will help you transition from the classroom into employment. Next slide, please. So these are the 4 major areas that we really think about in industrial biotechnology: health, or the production of products for the healthcare industry, food and agriculture, again, the production of those things for the food and agricultural industry, biofuels, and then also just industrial chemicals. And so there's, benefits, I think, both to our healthcare system or to climate change and those things in all of these areas, right? And so we're talking about how do you, convert sugars, a renewable resource, into biofuels or into industrial chemical, and how can we replace some of the petroleum products using, metabolism or biochemicals or the metabolites that we can produce biologically. And then proteins are certainly a product that really is emphasized in terms of food and agriculture as well as in health. And so, of course, I've already alluded to this, that the idea of producing antibodies, which is, paramount to our society right now, is an integral part of industrial biotechnology. That's how we do it. We use mammalian cells or other cell cultures to produce antibodies. And you'll learn about in this program, you'll learn about how to design that plant and what are the important parts of designing those different biochemical processes. Next slide, please. This is actually one of my favorite slides and one of my favorite things to talk about, because it's been actually quite striking to me to learn some of these numbers, that the industrial biotechnology sector in the United States is really quite large. It's actually, this is value is a little bit old. It's nearly $400 billion in revenues from biotechnology alone. And that's a scale that's bigger than car manufacturing in the United States, as well as many others. And so, this is a large industry that we don't often explicitly talk about. And maybe this is something that's starting to change now when we talk about vaccine production, because this is, vaccine production is integral to this, or it is, integrated within the system, right? And so how do we produce the RNA and the lipid bodies that are used to make the vaccines from Moderna and Pfizer? Or how do we have the Johnson & Johnson one, which is also manufacturing? These are, important, current industrial problems that we're trying to solve. And so what's shown here is the industrial biotechnology revenues that are $400 billion total, and about 1/3 of those revenues go towards industrial chemicals. That's the production of things like ethanol or some others. Sorry, that was my email is clicking off. Biologics, which is certainly antibodies and vaccines, or GM crops is the other third of it. And so if we just go to the next slide, I think it'll show you the courses. And there might be, oh no, sorry, this is a little bit more about the economic impact of industrial biotechnology, not just in the US, but in California. And so these are numbers taken from this 2020 report on the California economic impact from Biocom. And so there's about 1.4 million jobs total in industrial biotechnology in California. That's a lot of jobs, right? And this is nearly $4.5 billion in research revenues from the NIH as well. And really what this shows is that there's a lot of opportunity, I think, within California and within the United States. There are some questions in the chat. Should I address those now?
No.
No? Okay. All right. And then, so there's, really the take home point of these last two slides is that industrial biotechnology is an enormous industry in the United States, and particularly in California. There's about 15,000 or a bit more than that life science establishments. And what that means is that there's about 15,000 businesses or entities that address industrial biotechnology in California. And again, that's 1.4 million jobs. One of those jobs could be you in the future. I think the next slide just shows us the coursework that you'll do. And this is an important part, I think, of you understanding what we're going to teach in this program, especially if you're an undergraduate in chemical engineering or environmental engineering now. And of course, entry into the program can be from chemical engineering or environmental engineering. This past year, 2 years ago, we had somebody who was just a chemistry background who came into our program as well. And so we're interested in all different educational backgrounds to come in here. The program is really set up for chemical or environmental engineers, but we can have a discussion if that's not your background or that's not your undergraduate degree, and we can think about what other courses might supplement your work here. So in the fall quarter, you really focus on some introduction to biochemical engineering. And then importantly, you begin this design process. This is 238A, B, and C. It's a design laboratory that you'll end up working with the same group of people for the whole year-long course, A, B, and C, of course. and this is really where you'll really hone your skills of designing different bioprocesses. How do you manufacture antibodies? How do you manufacture these RNA vaccines? How might you do it with a lentivirus vaccine? How about ethanol, etc.? All those different processes you'll start to look for. Okay, I think I'm probably pushing my time here, and so I'll pass it off. I think the next slide is just into our master's program, but I'm happy to take any questions at the end. This is an exciting program. We're now into our 4th year of having that program, and I'd be happy to have any of you join us for the 5th year. Jin Young?
Yes. Okay. Hello, everyone. So I'm Professor Jin Liu. I'm the 5th year assistant professor at UCR. So right now I'm going to introduce the MS online program for the water engineering master program. So our environmental engineering systems program focused on exploring the science and engineering principles, which is essential to providing the clean water and improving the natural environment. So I'm not sure if you have the undergrad education background in environmental engineering, but if you did, perhaps what you have learned from the undergrad education is that as an environmental engineer, what you need to know is how do we apply or use the mathematical equations and find the right equation, put in the numbers and get the answer. So perhaps this is what you have learned from the undergrad environmental engineering education. But right now we have more and more challenges in the water area, such as perhaps you have heard from the news that the perfluorinated chemical is almost everywhere and almost in everyone's blood and in the food and in the drinking water, and we need a solution. But there has been no established method so that you won't get any information from the menus or some established software, so you won't have any clue on how to deal with that. But by taking our master program, you will really learn something that is really the cutting edge and very useful to treat the PFAS, the perfluorinated compound contamination problem. And we know the DoD and many other chemical industries are allocating the money to treat this huge environmental challenge, and this is a $1 billion scale opportunity for the environmental engineering area, and especially the water engineering area. Okay, so it's a $1 billion scale remediation project. And at the same time, we perhaps also learned about the emerging contaminants, which can be the carcinogenic species during the traditional water treatment process, or some endocrine disrupting compound by the domestic wastewater discharge, the unused pills directly dumped into the toilet so that they become the pollutant in the water source. So these are also some focus that our master program will teach you how to deal with. And perhaps we also have learned about the pathogens in our drinking water supply. So perhaps they can be the virus or some cyst or some pathogens. When you turn on the shower tap, you can breathe in some bacteria, and that can be very, very dangerous. And how can we monitor and deal with that kind of challenge? And perhaps you also have learned about how to get a resource recovery from the wastewater. The wastewater contains organics, which can be the source of energies and the source of the nutrients and even the heavy metals, the precious metals. How can we get them from the water? And especially in Southern California area, we have a very scarce water supply. So we also want to use the water, reclaim the water, called the water reclamation. So how can we deploy the new technologies in order to save as much water as possible? So this will be the huge saving, because water industry is always dealing with the giant amount of the water supply. So this specialization of our master program will incorporate the elements of water treatment and chemistry, because we have the combination of chemical engineering and environmental engineering, and you will get the degree of both chemical and environmental engineering. So we have the focus and expertise in the chemistry and biology part. So the representative topic will be the water system fundamentals and physical chemical process, biological treatment, and advanced technologies. Next slide, please. So this table, you can see these are the fundamental courses you are expected to take for the MS online program. So there's no clear date that exactly when do you want to start. You can start from the fall, you can start from the winter or spring or the summer. So you can take this, start the program anytime. And then these are what you're going to take. So first, there are 4 fundamental classes, including the engineering in the global environment, technology innovation strategy for engineers, and introduction to system engineering and principles of engineering management. So these courses will provide you the basic knowledge on how do you apply the specialized knowledge in the broader area. And you will actually really benefit in your real work. And then regarding the specialty courses, we are currently offering 4, but there are going to be more in the near future. So these courses include the water chemistry in natural and engineered systems, and physical and chemical separation process, biological treatment process, and advanced water treatment technologies. And you will also take the project design courses, and that will be spread out into the 4 quarters while you are in the program. So I'm also serving the graduate committee, and we also participate in the graduate admission. And every year there are many PhD applicants. Okay, so the PhD applicants have already taken the courses in other master program in other universities. So here I want to say a little bit more about why our program is so unique and advantages if you want to study the water treatment technology. First, as I just mentioned, we are the combination of chemical and environmental, and we have the focus with expertise on the chemical side and biological side. And when I reviewed the applicants with already taken the master program at other institutions, I can see that they have their master program set a very broad coverage of the environmental topics. So that can include some water and some, for example, the sustainability and some other modeling classes. But what my point is, if you want to take everything just within the limited amount of time, such as 1 year or 1.5 years, then if you want to take everything, then the depths of the knowledge you're going to get will not be deep. But if you really want to make the best use of your master's education experience, we really need to learn something very deep. And this is why we have the advantage that you will get intensified education in these 4 water engineering courses. And for example, I'm teaching the advanced treatment technology right now. And what has been covered in my class include some carbon absorption and ion exchange, which is not offered in many other places as far as I know. Okay, so these technologies are very useful in treating the perfluorinated chemicals. And I also share the immediate discovery in my lab on how to destroy the perfluorinated chemical. Perhaps on the TV or the TV news or the newspaper, you have learned that the perfluorinated chemical is called the forever chemical. But actually, my point is that the perfluorinated chemical is not forever chemical at all, and it's even easier to be treated than the traditional organic compound. And if you are in our master program, you will immediately find out why. So why we're so confident in treating the most difficult chemicals, and why you can, after having this kind of knowledge, you will be very competitive on the job market if you want to work in the water treatment industry. So on this slide, you can see there's some brief introduction with generalization on what is covered in these 4 classes. So for example, the water chemistry will be some advanced level beyond what you have learned during the undergrad education, because we know the undergrad classes cover some water chemistry, but not very deep. And you're going to have a comprehensive coverage on all of the principles, including acid-base and metal interaction and solid precipitation, redox chemistry. So these are very, very useful in the real engineering. And for the biological process, so this class, the 226, mainly focus on the wastewater treatment plant, because wastewater treatment rely on the microbial activity, and you will get a very deep understanding of all of the process. And for the physical chemical process, so I would suggest perhaps we can change the course name in the near future, because this class mainly focus on the water treatment process. So this this is regarding the drinking water treatment, and 226 is regarding the wastewater treatment. So we cover everything, and you will know the details and challenges and technical solutions on all of the aspects in the water treatment technology. And for the 243, the one I'm teaching right now, besides the new knowledge, I will also provide the discussion on comparing the graduate study, the academic study, and also the real engineering work. So perhaps you also get some useful information on, do you want to continue for the PhD, or you want to directly get the job in the market after getting the master's degree. So I firmly believe that you will really benefit a lot, and by learning some knowledge that you won't get in many other environmental engineering programs in the United States. Next slide, please. Okay, so currently we have 4 faculty members, and as I mentioned, we have the combination of chemical environmental. So you can see that we have two faculties working on the chemical side, and 2 faculties are working on the microbial side. So we have the broad topic coverage, including the water reclamation, water treatment and reuse, advanced oxidation, disinfection byproduct, and also the catalytic treatment of perchlorate, nitrate, perfluorinated chemicals, and how to use microbes to treat the wastewater, and how to control the pathogen and mitigate the risk of the biological threat from our drinking water supply. So we have the comprehensive coverage and high expertise, and I really hope you will enjoy our master program in the water treatment engineering. Thank you.
Thank you. And this will be the last of our presentations anyway, and I'm going to be focusing on air quality. I recognize some of the names on the participant list, and so I know that I've had some of you or have some of you in classes. But for the rest of you, my name is Don Collins, and I am one of 4 faculty members in chemical and environmental engineering that does air quality research and teaches air quality classes. Next slide, please. So just very quickly, a summary of some of the courses that we have in our department and throughout the university that focus on different aspects of air quality. And aerosol technology is a relatively new class, or at least it's being taught for the first time in a while. And that is relevant for many of the types of pollutants that we have in the atmosphere. The next 3 classes in that list are all graduate level courses, including the first one, which is a brand new class that is taught by Dr. Sunny Ivy, who you met briefly earlier. Advanced Air Pollution Control and Engineering, which is a course that we offer or have been offering for the past several years. And then a course that we are going to start offering again as part of the Air Quality Masters that I'm going to be describing later, titled Vehicle Emissions Control Technology. And there are some additional undergraduate courses, 2 of which are listed there: Technology of Air Pollution Control, Combustion Engineering. And then, as I've indicated on the bottom, this is just a partial list, but there are several other courses that are relevant for air quality and that are being offered around the university. And so, as I'll highlight at the end, we have developed a pair of master's programs, and one of those includes a number of electives that students can select from. And anyway, that gives students an opportunity to take some of those courses that are outside of the chemical and environmental engineering department as well. Next slide, please. So I just wanted to briefly comment on some of the reasons that air quality is important and will remain important. I think that for many of us, last year has given us a little bit of whiplash regarding air quality in California. If you remember, at the beginning of the shutdown, there was a lot of enthusiasm, a lot of optimism about how clean the air was, and this was evidence that somewhat reasonable reductions in emissions could result in really dramatic improvements in air quality. And that was soon followed by a pretty bad summer in a lot of different ways. The photographs on the right-hand side that may look familiar are days with very heavy smoke from the numerous wildfires that we had in Northern California and Southern California. And then on the left-hand side, which is at least partly connected with those wildfires, but also related to emissions that we more often think about from cars and refineries and all sorts of other sources, the ozone concentration in Los Angeles reached the highest that it had been in decades. And this was true in a lot of other areas as well. So the bad news about this is that it was a challenging year in a lot of ways. The good news is that for anyone graduating in this field, this is going to be an area that is going to be receiving attention for many decades to come. Next slide, please. I wanted to just very quickly provide a bit of an overview of the work that's being done in the department, highlighting some of the research that is done in our labs, and then in the next two slides, some of the research that's done in the field by our faculty members and some work that's done using computer models. But starting out with some of the laboratory work that's done, these are a pair of photographs from one of the centers that was described briefly earlier. This is CERT, which is a research facility a couple of miles north of the main campus. And as you can sort of appreciate, the atmosphere is really big, and some of the techniques that are required to understand the atmosphere in the lab require big facilities as well. And the image on the right-hand side is of a large chamber facility, a big Teflon bag that's used to simulate chemistry and the pollutants that form in the atmosphere. And then on the left-hand side is a similar facility, but specifically used to understand the chemistry associated with emissions from cars and trucks. Dr. Cocker, who you heard from very briefly earlier, is the one that does most of this research at CERT. Next slide, please. Some of the work that I do is shown over on the left-hand side. We've been using drones to study profiles of different pollutants. We've used them for some other applications as well. Dr. Kelly Barsanti, who is the only one in our department that does air quality research who is not joining us today, is very involved in research associated with wildfire smoke. And among the projects that she's been involved with was collecting samples from onboard a research aircraft and studying the emissions from different wildfires. And then on the very right-hand side is some field work that Dr. Ivy does, where she asks different participants to wear those lightweight and portable monitors that are shown on the right-hand side to assess the exposure of individuals as they spend time indoors, outdoors, on the road, and everything else that we do. Next slide, please. And then finally, in terms of the work that's being done in the department, I note here that there's also a lot of computational work. And the slide on the left, or the image on the left, is one from some of the computational numerical modeling that Dr. Ivy does, looking at the or simulating ozone production and its response to different emission sources. And then on the right-hand side is a highlight of some work that Dr. Barsanti has done, trying to use the results from those chamber experiments that I showed in the first slide to improve these atmospheric models and algorithms that are used within them. Next slide, please. In addition to the four of us that are in the chemical and environmental engineering department, which are the ones that are surrounded in red in this image, there are many others throughout the university that do work directly or indirectly related to air quality. It's a really unique university in that way. There is as much of focus on air quality here as at any other university in the country, and far more than the average university. Next slide, please. And I wanted to point out something that's really exciting and is going to to be realized very soon. Some of you may be aware of this, but the California Air Resources Board, which is a state level agency, as you can understand from the name, that's responsible for maintaining air quality and is also a leader in work being done to address climate change, has a headquarters in Southern California that is currently in El Monte. And a few years ago decided that they had outgrown that current facility and needed to move. And there were a number of locations, a number of cities that tried to recruit them. And in the end, it was Riverside that won. And part of the reason for that, or part of what made the offer so lucrative, is that they offered land that was previously owned by UCR. It's in the Citrus Field area, just on the other side of 215 from campus. And they, the satellite image on the right-hand side looks like it's just a big dirt patch. The building is almost complete, and they will be fully staffed in less than a year. And at that time, they're going to have on the order of 400 employees. So it's an enormous facility. It's really exciting. It is going to be an opportunity for students from UCR to get involved through internship programs and in other ways, and hopefully many of them will stay on and become employees. Next slide, please. And then finally, I end this with a summary of the 2 air quality focused master's programs that we have recently developed and are currently moving through the approval process and will be active by next fall. The one on the left is most similar to the industrial biotechnology masters that Dr. Wielden described earlier, with, as you can see in the summary, a set of 4 core courses that all students will take, including air quality modeling, that advanced air pollution control and engineering course, the vehicle emissions control technology course, and one focused on energy, as you can see, the production uses, economics, and sustainability, together with 4 electives courses from a list of 18, including some of those that I showed on that first slide. And then on top of that, we borrowed the approach that Dr. Wielden developed for the Industrial Biotechnology Master's Program and require a 4-unit internship that students will do in the summer after their year of taking courses. And those, as I've highlighted here, could be at that new ARB facility just across the highway, or at other facilities not too far away, such as the Air Quality Management District in Diamond Bar, or EPA Region 9, which is their regional office. We simultaneously developed a master's online program, which is the counterpart to what Dr. Liu was just describing, and is structured in the same way. So the same 4 courses that are required for the in-person masters that I was just describing will be required for it as well. And then the 16 units or 4 courses, those professional engineering courses that Dr. Liu included on one of his early slides, together with the 4 units of the professional project design course that he also described. So we were really excited about this. I think that these are going to attract a lot of students, and I think that especially with the Air Resources Board opening up next door, it's going to be an exciting time. And I believe that's the last of our presentations. And so now hopefully we'll be able to answer some of the questions that you have.
I'll just jump in real quick to share with everyone a question that we got in the chat, and whoever would like to answer. Sounds like Ian, you're already typing an answer. Asking about, can BS plus MS students choose one of these curriculums, in case anyone else had that question too.
Sure, yeah, I can answer that. I was typing out an answer, you're right. Yes, any one of the programs that we talked about today is open to a BSMS student. And so again, the degree that you will graduate with in any one of the programs we described today will be a chemical and environmental engineering degree. And the choices that we've outlined today are just the specific courses and course kind of plans that you could take. That is the industrial biotechnology one, the air one that Dr. Collins just talked about, or what Dr. Liu talked about in terms of that water quality engineering. And so all of those kind of course structures are available to you. That's right.
We invite any and all questions.
I just want to quickly add to Professor Wielden's comment there. We also have the traditional chemical and environmental engineering MS track as well as these specialty tracks that are all available to choose from. And not only do we have all these nice specialized programs, we do have the more general MS in chemical environmental engineering. So lots of choices. Thank you, Ian. And I'll echo Sunny's, Professor Ivy's comment here. We're open for your questions. We're here for you. What would you like to know about?
I'll say a bit about, just a tiny bit. I did do a master's, a BSMS master's on the way over to PhD. It was a time for me to reflect about career options, and it gave me quite a bit of flexibility to take some time to understand what I wanted to do long term. So a master's can be quite beneficial for you if you're still trying to figure things out. We have a question from Josh. How has the transition to online affected graduate students and lab work?
That's a great question. Similar to what you've seen at the undergraduate level, I know Josh is one of our students here. The courses have been taught online this past year. We do expect a full return to on-campus teaching next fall. So for those students that would be starting an MS program in the fall, there shouldn't be any effect. As far as the lab work goes, our graduate students have also been given permission and have been working in the labs. We have had a lot of special protocols to ensure the safety, or at least to reduce the risk as far as possible of COVID-19 transmission, while still maintaining the operations of the research labs. So on the research side, that's just been ongoing. We've missed our undergraduates, but our graduate students are fully engaged. And Ian, I think, has a comment as well.
Yeah, there is one wet lab course that's in the industrial biotechnology program, and that is being run in person or hybrid this quarter. Again, certainly with social distancing and appropriate COVID regulations, or following those COVID regulations, and so that's ongoing, and that's the only one wet lab that we have in that program as well. Also, some of the internships should be able to continue, but again, those would be remotely. Either for a lab or for industry as well.
Our next question is choosing a specific path, for example, biotech, air, or water, better than the general CEE, environmental engineering master's degree for jobs or internships?
I can answer that. I think, in my opinion, I think that the answer is yes, that these dedicated programs will give you a defined set of skills that you can translate from the classroom to industry. And I think Dr. Liu kind of, highlighted that in the water program, and Dr. Collins also in the air program. And these are, courses and sets of courses that we've designed to provide you with a specific set of skills that you can translate to industry. That's not to say that a typical master's program in chemical engineering or environmental engineering won't also provide you some, valuable skills. But, you know, in the industrial biotechnology one, you're going to spend 9 to 12 months really dedicated to one topic. And that's the same for the other programs as well. And I think that gives you an opportunity to really go quite deep into that topic and to learn those new skills that you can translate directly into industry. And that's the intent, or that's the design of those programs. So I think the answer is yes.
Wonderful. How early can students apply for the MS Biotechnology program?
Applications are open now, and we'll take applications through the summer. But the sooner that you indicate to us that you're interested in the program, the better it is for us to prepare for next year. But you'll be able to apply to that program now and through the spring quarter, certainly. And that's true for any of the master's programs.
Okay, we have a question from the chat. Are there any scholarships available for international students for the program, for these programs?
Generally speaking, there are not a whole lot of scholarship opportunities for the MS level programs. There are a few very specific scholarship programs that you can apply into. CCERT has an open competition on the air quality side that MS students are eligible for, and international or domestic. And in some instances, those pursuing a MS thesis option will be able to identify a laboratory that could help support them. But for the general coursework masters and for most of these specializations, there are not a whole lot of scholarship opportunities available.
Wonderful, thank you. We have a question that says, I have already been accepted to BSMS program, but I may have 1 or 2 breadth courses to finish in the fall of 2021. Will I still be able to start the MS courses in the fall?
I don't know the answer to that one, David.
I was just about to say the same statement as Ian over there. I'm not sure what the answer is. I would encourage you to email that question over to Professor Collins, who's in contact with the Student Affairs Office, who can get you those answers. But unfortunately, I do not know the specifics, and I would really hate to lead you astray.
I suspect that the answer might be yes, but you'll still be an undergraduate for fall and then transition to a master's program in the winter. And then you might need 1 extra quarter the following year, but I'll leave it to, that's my guess. That's my best educated guess. And please, let's follow up and get a firm answer. There's one more question here, and I was going to type it out, but I'll answer it live instead. The question is, if you're an undergraduate now and you apply towards the biotechnology program, do you need to shift your concentration in undergraduate? The answer to that is no. I think that actually you would benefit from maintaining whatever option you are in now, and that might be the general chemical engineering option or environmental engineering option. And in that case, you know, you'll move right into the biotech master's program, which uses one of the courses, actually 2 of the courses that you would do in that option anyway. And so if you do them this year, or if you do them next year before you move into the master's program, you'll just have to replace that with something else in your first year of the master's program. And so my suggestion would just be to maintain on your typical track that you're interested in, and then during the master's year, dedicate time towards industrial biotechnology. And we'll certainly have enough time in that 9 to 12 months that you're with us to really convey all the skills that you need.
We have another question. As a BSMS student set to start in the fall, what would you suggest for preparation for the program? For instance, are there ways to get involved somehow this summer?
I think the best way to get involved, and this is of course pending how COVID-19 moves through, would be to get involved in one of the labs on campus. If you're planning to be here for the master's program, it would be a great time to to contact faculty in the specialization of your interest and to really get involved. Of course, again, that is pending clearance from the chancellor's office for allowing students in. Likely, we already have that clearance, but again, I have to tread with some caution as I can't foresee exactly where we will be in a few months. That would be my recommendation for preparation. I don't know if there's any recommendations from Don or Ian on top of that.
I would have said the same thing.
Yes.
See.
Oh, okay. So we have another question. Ian, were you going to take that one?
Sorry, I just said that one was answered that I didn't know the answer to, and I think that was a water one. I'm sorry, I pushed the wrong button, but I'm going to answer the last one, which says the required GPA. The required GPA for the BS MS program, I believe, is 3.2. Overall, for entry into the master's program, it's 3, but we're flexible.
Yeah, so
Jin Young, sorry, Jin Young, there's a water question that I said was answered, but was not answered. If you could look at it, that'd be great.
Which one?
Yeah, so I'll give it a read. I know the Master of Science in Engineering with a specialization in environmental engineering systems, water specialty, has been 100% online pre-COVID. So has research and labs for this always been online? So this is in regard to the water quality masters.
Oh, okay. So for the MS online program, it has always been online. So which means there's no direct lab experience by working on some lab research at UCR. So we don't have this setting, but we have the course, the project design, which will last for 4 quarters. So every quarter, you're going to work on the different level of for the single project. So initially, one year ago, yes, I actually worked with one MS Online student who worked in a water technology company. So that student designed a novel filtering system to detect and control some microbial contamination. So the student actually worked online with me. So I kept checking the design and also the report. So that's some effective way of doing the research, but we cannot offer the hands-on lab experience just through the online system, but we have the other solutions.
And just to follow up on that, I just want to make sure we're really clear here. There is an MSOL program, so MS online program. In there is where this water specialization option is. The air specialization option is also being created as part of the MSOL. We have in-person, of course, pandemic allowing, programs in general chemical environmental engineering, the biotechnology, as well as again in the air quality. So there are 3 in-person masters that we are discussing and 2 online masters. And the MSOL program is separate from the BSMS or MS program. So the MSOL is a strictly online, where BSMS is a traditional and would be on the tracks of the biotech, the general, or the air quality option.
Yes, so I also want to add that I have worked with some students who might be just recruited as the standard chemical and environmental engineering master student. So we offer the lab research for this kind of student on campus.
Right, and within the masters, the CEE masters, there is both a coursework and a thesis based. And Professor Lewis referring to the thesis based, yeah, which you are with a thesis, you specialize into anything that you are interested in that you find an advisor for inside of our department. Good questions and comments.
that, I'm going to go ahead and transition to our Connect with Us slide. But please continue to put your questions in the chat if we haven't answered something that you are curious about. So we have one more question. Can you compare undergrad to graduate courses? Are they structured the same way? Are they structured the same, for example, final exams?
I guess I can say for the biotech program that there's a mixture in here, that some of the courses you're taking, you'll be taking as a master's student, but taking the senior elective undergraduate course. So that course, like biochemical engineering or introduction to biochemical engineering, CHE 124, oh, excuse me, is similar to your undergraduate experience. But in something like the process design course, which is, all your, it's a small class with just your, classmates from this program or from the biotechnology program. And so that could be 3 or 4, 5, 6, 7 students that structure is much different. And that's really kind of project oriented. As I've taught it, it's typically been, let's kind of treat ourselves as a small design firm and try to answer questions that we think are relevant to industry. There isn't a final exam in that course, but there are projects. And so I think that the structure is quite different across different courses in every program. And so there'll be some lecture-based courses that are more traditional, and then others that you've heard, of course, across all of these different topics, all include a design course. And so those will certainly be different, or at least that's the answer from the biochemical side.
And I think that's really true across all of them, is that we have a mix. Some will feel more like your traditional bachelor degree classes, except they'll be more advanced in what's being covered. And then you'll have some of the more unique classes that Professor Wielden was just describing. So it's a mixture to make sure that you have that specialization that fits your master's degree.
Well, with that, we're ending the end of our winter quarter Master's Open House. I'd like to thank our faculty panelists, our chair, Professor Cocker, and for you all that showed up today, our attendees. And please feel free to follow up with any questions at the email listed there, gradcee@engr.ucr.edu. Or if you had a specific question in the chat, please follow up at gradadmissions@engr.ucr.edu. And with that, thank you very much. And we look forward to seeing you in the fall.